The way this audio circuit works is very interesting on this radio, so I'm going to walk you through how this circuit operates. So the first thing we're going to select is we're going to select the pickup input, the TA input, which is this jack over here, and we're going to select stereo. Okay? What this means is that all the switches that are related to the pickup and the stereo will be activated and therefore change their state. Now, as we can see, their natural state is shown here and here on the off position. Now, if we activate it, we get this. They literally flick over. Okay? So when we're running stereo into the pickup input, the switches are now in this position as you see it here. What we're going to do is we're going to take a signal and we're going to run it in from the inputs. And I'll show you then what happens to these signals as they move along. So let's start with the left input. Okay? Let's call this the left input. Signal goes in here, goes across there, and at this point it meets two paths. One is through this resistor network with a capacitor in the middle. The other one is through this 10 nanofarad capacitor. There is in fact another path up, which is into the output to the tape recorder. We're not looking at that now, we're not interested in that, so ignore that for now. So the first thing that happens is that the bulk of the signal goes through this 10 nanofarad capacitor. I say the bulk because 10 nanofarads is high enough that all frequencies get through, with the exception of some of the very low frequencies. Maybe below 50, 40, 60 hertz, it starts dropping off. Okay? Then the signal gets to this point and it goes across to the switch. This switch is open or closed in that direction, so it goes across there, goes up here, goes across here, and when it hits this point, it's entering a tonal shaping stage, so tone control section. So we'll stop there for now and look at the rest of the signal, which we left off here. When it goes from here, it goes across that point there. Now, because there's a capacitor down here, the capacitor bleeds off high frequencies. So what we have here really is a low-pass filter that allows low frequencies through while cutting the high frequencies. And you'll see in a minute why that is so important. Because this signal, the low frequencies of our left channel, now goes up here, meets that switch, which is connected through, goes up that way. And let's stop there for now. It also goes back, coming through to the tape recorder, but we'll ignore that. Okay? The right channel does basically the same thing. It comes up here, goes across there, it goes up here, there's the tape, forget it, it goes across this 10 nanofarad capacitor, and it now has the path that we've seen before going upwards. So this signal, which is the full right channel, the purple, is joining with the low frequencies of the left channel. Okay? So what you're getting up here is the full right channel plus the bass frequencies of the left channel. And then it carries on further down here because it gets to this point down here and it does a similar thing. It goes across that resistor to that capacitor bleeds off some highs, it goes through there, and now we're back to this point, which, if we follow this path, joins that signal. So what we've actually done is we've kept the full range of the left and the right channel to the left and to the right, but we've also summed to each one of those the bass frequencies of the opposite channel. So what you have up here, for example, is the full right channel plus the bass frequencies of the left channel. What you have down here is the full right channel plus the bass frequencies of the left channel. Then it arrives at this point, which is the tone circuit. If we basically ignore the tone circuit's function, because to properly analyze it, we would have to literally go through, probably do a SPICE simulation or something similar. But very briefly, what you get here is you get the bass control down here. There is the highs, the treble control up here. There's a switch here, which is actually the jazz switch, which gives you more or less mid-range, less highs, more highs. So basically what happens is this whole section here shapes the tone until that signal, that combined signal, arrives at this volume control. And when it arrives at this volume control, it's ready to taper off into there. So you have a shaped signal of the right channel plus the base of the left channel going through this volume control, and you then select the level that's going into that capacitor. We'll follow that in a minute. Now, this section has one other interesting aspect, which is these taps that come off the volume control at various levels. This section allows you to get more bass at lower volumes, so it allows you to get a richer sound even when you're playing at very low volumes. Otherwise the sound would be very tinny. This is in effect a original version of a bass boost or a loudness control on these radios. Now we've looked at this channel. Let's call this purple the right. Let's go up to the top. And again you have this signal coming into the top of the volume control, and you would then select it off and get the volume you want through this capacitor. So what you have over here now is you have a situation where you have created two channels of audio. The top one is the left channel plus the bass of the right channel. The bottom one is the right channel plus the bass of the left channel. And these are now ready to go into the preamplification stage. So let's look now at what happens to the signal when it comes in here, and looking at the one side only for now. The signal comes in here. It's come through the volume control. You control the level of the signal to whatever you want. Now the signal is here. So the signal comes across, and we notice that it goes straight into the grid of that triode. It's half of an ECC 83. Now there's also a path down here which doesn't go anywhere because the switch is open, so that goes nowhere. There's that resistor over here, which is a 22 mega ohm resistor. It has to be connected to the cathode over there because that switch there is also open by the action of the pickup select switch, okay, similar to that one. So this resistor here is effectively creating a negative voltage, a bias, at the grid of this triode. And the reason that works is because of the very, very high value here. The electrons that are basically leaked out of the cathode form a negative voltage over there, so it's a self-bias situation. Okay, it's one way of biasing a triode. Now the other part we see here is that this path here is closed, so because of the TA switch, that path there is closed, and what you have going on here is it gets to this point and it meets 150 ohm resistor. Now this 150 ohm resistor effectively raises the ground, if you want to call it, of this signal level of this triode to that point. It's going to raise it slightly because you've got cathode current flowing through here, it gets to here, it comes down to ground, it creates a voltage across here, so this voltage here will not be zero, it'll be maybe 150 ohm, probably about 3.5, 4 volts, but it raises it slightly. And the reason they raise it is because you've got another resistor here, which we'll ignore for now, but it comes from the speaker output. It's basically the feedback that's coming in here to the to serve as negative feedback into this amplification stage here, this preamp stage. There is also this D over here, which is basically a potentiometer that's connected. We look at this side for now. It's connected at this point and it's connected to ground. So you can imagine if you move this wiper all the way to the left, you are shorting this point to ground. Okay, what this is doing is basically acting as the balance control. Again, not that important for now. Let's ignore it. But what we do have, which is important, is this triode over here. And this triode is very interesting because it's doing two things at different times. In this situation that we've just seen, we've got the grid and the cathode wired up as you normally would with a normal triode amplification stage, in this case a pre-amplification stage. But what happens to the rest? Well, if we look at the anode, the signal coming in here in a normal triode amp, the anode would have the signal coming out here, okay? But for that it has to be connected through a load resistor, the anode resistor, the plate resistor, to B+. Now, is that the case? Well, if we look at this line here and follow it up and across, we meet this resistor over here. Now, that resistor over there is interesting in that it's 470K and it's connected to this point, which is actually B+. If you follow it down here, it goes to this line, which goes to the B+ line, one of the B pluses, okay? So we've got B+ coming in here, up there, across there, through that resistor and to the anode. What we have now is a typical triode amplification stage. That being the case, that means that the signal that comes in here is amplified. It's actually inverted, but that then comes out here at that point through that capacitor, 3.3 nanofarad capacitor. It meets the switch, but it goes across the switch, goes there, through that switch, and now it comes down here. And down here means that it comes across this way, it goes up there through that capacitor, and it's actually the signal that feeds the grid of this pentode, which is one of the output tubes, or the output pentode. So this preamplification drives this output power tube, okay? If we look at this top one, we've got a very interesting configuration as well. What we have here is a similar situation in that the signal comes in here and drives the grid of this triode, which is the other half of the ECC83 tube. This triode also has a grid leak resistor of 22 meg to the cathode, so we can see that it's creating its negative bias to make it act as an amplification stage. There is a 390 ohm resistor over here. This resistor goes to a 150 ohm resistor. Now this 150 ohm resistor sort of looks familiar because if you follow it back up here, it meets another 5.6K coming from that side, like the one below, which again is a feedback resistor, negative feedback from the speaker output at the top here. But we'll ignore that for now. We're ignoring a hell of a lot, but hey, you've got to do this to look at the basics of the circuit. So well, let's call this basically the ground, okay? This capacitor is connected to the cathode, but it's also connected. This is one of the tonal select switches. We'll ignore that. It goes across here through that switch to ground. So this capacitor basically bypasses that resistor. So this is our cathode resistor with a bypass, okay? Now, again, if we look at this triode, if you have a signal coming in, if this triode has B+ on here, it'll actually amplify. Now, is there B+? If we follow this up here and we go across to here and we come back to this point here, this resistor, a 330K resistor, and if we follow it down, we find that it comes to exactly the same point that fed that resistor its B+. In other words, we have B+ at the anode of that triode. So this triode is going to amplify that signal, invert it, and it'll come out here. That audio signal comes out here and it meets this point. Now it's going to go down. Let's see what happens if you go down. If you come down, we meet this switch selection and we notice that they're all open switches. So it doesn't come down, okay? So it's got to go somewhere else. Well, where does it go? It goes to here. Ignore that one for now. And it goes through this coupling capacitor. There's a resistor to ground, which looks similar now because if you follow this line across, it goes into pin 1 of that tube. Now that tube is the magic eye tube. which is very unusual, but this Magic Eye tube has a spare triode, exactly the same, well, close enough to that one. And the way a triode works is you have a Grundig resistor, which is that one over there, and if you have B plus on here, you'll have that signal inverted and amplified. So do we have B plus on here? Well, actually we do, because if we follow that resistor back, we're back to the B plus line. So that triode is being fed with B plus, which means that the signal comes out here. Now the signal that comes out here is that one, amplified and inverted. It goes back up here, it goes across there, it goes down there, and yes, you guessed it, it drives that pentode, the other pentode that forms part of the ELL80 power tube. So what we have here is this signal here is amplified and inverted, goes across, it gets amplified and inverted, goes across, and it feeds the triode. So this signal gets inverted twice, once there and once there. Okay? Just remember that point for a minute. We'll discuss it in a second when we look at the other channel quickly. This resistor here is a negative feedback resistor to that input. And the way it works is you have this signal, remember it goes down here and it gets inverted and amplified. Now if it's inverted, that signal is the reverse of that one. So if you join them, you are subtracting from it. You're giving it negative feedback. And what you want to do here is you want this stage here to give you an amplification factor of -1. You just want it to invert the signal. And we'll see why we want to invert that signal. Basically, you just want to invert it. You don't want to add to it, subtract from it, multiply it. You just want to invert it. So you want a gain from here of a -1, as close to 1 negative as possible. And this is how that value is achieved, is arrived at. That value is slightly higher than that one to give it a gain of -1. Now, this is comparable to an inverting op-amp circuit, okay, where you have the feedback resistor, that's RF, and you have the input resistor, RI, and the ratio of the two would give you the gain. Well, that only works if the amplification stage is infinite gain, okay, and you control the actual gain by the combination of resistors. Because this has not got an infinite gain, that one is slightly higher to compensate for that and to give you that -1 multiplication factor. So what we have now is this signal going through there, through there, through there, is driving that tube, okay? There is one other thing that needs to be looked at here, and that is this, this triode. Obviously, part of the biasing of this triode is it needs a cathode resistor, and it does have a cathode resistor. This is the cathode resistor here. It actually goes through that. It's not shorted to ground because when you activate TA, that switch opens. That switch needs to be open as well. My mistake. So you've got a 6.8 plus 3.3K resistor to ground. That's the cathode resistor. It's bypassed with a 50 microfarad capacitor. So this is a typical triode amplification stage with a gain, in this case, of -1. Looking at the full audio stage to this point using stereo and pickup input, this is what we've got. We've got this pentode being driven, and we've got this pentode being driven. Now what we need to do is we need to look at the how these transformers are being driven, and therefore the speakers, okay? So let's focus on this stage here. Let's focus on this stage here, okay? What we have here, if we look at the base frequencies first, okay? So what I'm interested in is what happens in this transformer, which is the base transformer, okay? It's being fed with B plus from here, this line here, as we've seen before. The stereo switches are activated, so that small capacitor is shorted, meaning that this primary has a 100 nanofarad capacitor across it. What it's basically doing is passing all high frequencies through it and not really through the transformer itself. So high frequencies are getting ignored here. What happens to the base frequencies? Well, the base frequencies, if we look at this channel, the signal comes out here, through there. Base frequencies are being ignored by that transformer because it's a very low inductance. It's a small transformer. It's in single-ended. And then it comes down here and it basically drives this part of the transformer on the up signal. What we've got at the same time, if you remember, we have the exact same base frequencies on the other side because they summed in the beginning. However, they're on the other side but inverted. So what we're getting is this pentode is driving the opposite cycle through this half. So what we've got here is a typical push-pull amplifier. However, the push-pull is only for base frequencies. So this pentode and that pentode is driving one transformer, the base speaker transformer. Base frequencies, push-pull, okay? Now the high frequencies are different. If you recall, this side has got the entire range of frequencies, including the bass of the left channel, and it also has the bass of the right channel. So now we ignore the bass frequencies. Let's look at the mid-range to higher frequencies. These are being pumped out here similarly to the bass frequencies. It goes up here, along here, but now this transformer reacts to them. And this transformer is the one that operates and creates the sound from the speaker. It's a lower inductance. It's basically primed for the mid to high frequencies, and therefore it drives this transformer, but it's in single-ended, okay? And what happens to this path? Well, this path, the high frequencies don't really see this transformer. They see this capacitor. The DC section, the DC connection to that transformer and that anode still goes through, because effectively at DC, this primary is basically an inductor. It just reduces the ripple, okay? So DC is feeding that anode plate, but as far as the audio is concerned, it doesn't see this. So the only load that the mid to high frequencies has on this pentode, on this driver, is this transformer, and therefore that speaker produces that sound. The same occurs with the other channel. The sound is induced in this transformer, bypasses that one through that high capacity capacitor that we have here, and it induces that signal, that sound, on this speaker. Okay, so we've basically got ourselves a push-pull and two single-ended amplifiers here. The very high frequencies are the ones that are transmitted to this electrostatic tweeter. So this sound, this full range left channel, goes through there, the signal comes out here, through there, to the tweeter, which has been charged with B+ through this resistor that comes from that B+ line. And that's basically what we have. We have the full audio looked at in as much detail as I care to look at right now. There are quite a few other things. There's a feedback path. You remember I mentioned these resistors, this one here and this one here. Now, if you look at this resistor, it comes from this point, it goes up there, and it basically joins the speaker, because this is the external speaker socket. When you plug in a socket, it disconnects the internal speaker, but ultimately this resistor, this path, comes from that speaker. There, down there, through that resistor into that. If you look at the other side, we've got a similar situation. You have this point here, comes back here. It joins two parts actually, because this path here is a feedback to that triode amplifier, negative feedback to that triode amplifier. And this one here, this path here, goes along there through that 5.6K to the same point of the 150 ohm resistor to feedback to that triode amplifier. But from those points, you also have this resistor 1K going to this point here and 1K coming to that point there. There's a resistor to ground, and it meets another tone shaping circuit here, that VUN. Now the VUN one something, whatever it is. What it is it basically brings into play the two internal selectors of the graphic equalizer on the front of the radio. We have the bass on the left, the treble on the right, and we've got two other frequencies that can be adjusted. When you activate VUN, it's those two that you're adjusting. Okay? If you choose orchestra or if you choose jazz, those aren't activated. Okay, so that's how our audio works. I hope that this actually clarified something rather than confused people, because it was done, I did it so that I get an understanding of how this works. And I've gone further, which I'm not going to do here because it can get extremely boring, but if you care to, you can do that. You can now take the same example we've had here and not activate stereo, for example. And then you find something equally interesting. When you don't activate stereo, this whole switching system here and here takes this triode out of the audio circuit and uses it as a driver for the Magic Eye tube itself, because it then gets a signal from this line at the bottom here rather than getting one of the channels. The audio is linked in one point only that goes through that tone shaping, through that triode. That triode then has this signal here, which we looked at before. It went down here and it met two open switches. But if you disconnect stereo, those switches will no longer be open, and you'll end up with a signal going through here and down to drive this pentode. So that is driving that directly, and that is also driving this one, inverting, so you get the same effect on the two output pentodes. One push-pull function and two single-ended functions. Guys, I really hope that you're all, or not all, asleep, and that this has served some purpose. And yeah, it's a bit long-winded, but once you break it down into this sort of procedure, and you draw the switches in, that's the most important part. If you draw the switches in and you label them properly, this thing actually becomes quite easy to understand. Now, understanding it is fine, but when you look at how somebody came up with this, I think it's amazing. I think those engineers were amazing. This is a very, very smart circuit. I'm surprised it wasn't used that much. I think probably because later, very short time later, the idea of using one transformer for basically for a central bass speaker changed, and they started using separate left and right channels where they would actually use a crossover network to separate the bass from the higher frequencies. So you didn't have this requirement anymore. You would have separate channels completely. This one was a good compromise. Another thing you saw change very soon after that is the use of this ELL80 was not that widespread. This was a very clever idea. They were able to do two pentodes in one. So if you can imagine, if you have push-pull amplifiers for a left and a right channel, you would have one pentode for your left channel driving a push-pull transformer for the right channel, and you'd have the other two pentodes, the other ELL80, using it as push-pull for another push-pull transformer for the other channel. Whew, okay, right, that's enough for now.